Okay, so in this video, we want to see how we can find the mean, also called the expectation, of a continuous random variable x. The mean and the expectation are synonyms also for the average value of the random variable. So suppose that we have a random variable x that can take on values anywhere between a and b. And suppose that its density function looks something like this. Now, the mean and expectation, as I've said, is simply the average value of x, and it kind of is the center of the probability density function, which we'll call here f of x. And if you look here, the center looks kind of somewhere in here, right? If you think of kind of half of the area on the left and half on the right, looks about here. And we denote the mean expectation of x by mu. This is the Greek letter mu, which is simply an m. M, of course, stands for mean. And we can also write, thinking of mu being the expectation, we can write e of x, uppercase E for expectation, of the random variable x, so uppercase E, bracket of x. The question is, how do we find the center of the distribution of the density function? Well, if you think about this, so the mean, mu, is the expectation of the random variable x, the average value. Well, we have to look at the relative weight of each x value, and of course, the relative weight is given by the value on the probability density function. So we have to multiply the value of x by its relative weight, given by the density function, and we have to add all of those values over the entire range of possible x values, therefore from a to b. And of course we integrate with respect to x, and that's it. So if you are given a continuous random variable x, where all possible values are between a and b, and you have the corresponding probability density function f of x, to find the average value of the random variable, also called the mean, also called the expectation, you simply have to integrate over the interval of all possible x values, the product between the x values and the corresponding relative weight, therefore the corresponding value on the probability density function. And that's it.